Okay, now we're going to go through some limits approaching infinity practice problems. So we're going to look at different functions and what happens as x approaches infinity and negative infinity. So the first thing that you're going to look at when you're looking at a function as x approaches infinity is where your dominating piece of that equation is. So for example, if it's between 100, 5, and x squared, 100 and 5 aren't going to change at all, and x squared, as x approaches infinity, the x squared is the dominating piece. So basically what happens is, excuse me, that this will get towards infinitely large. So you're just going to have a big concept squared, which will give you another just big concept. And so as we kind of ignore the 5 and the 100, because as x gets infinitely large, they will become so minuscule in the whole equation. What happens is the biggest part of your fraction of your rational expression is in the denominator. So as your denominator of a fraction gets infinitely large, the whole fraction, as we talked about in that Edpuzzle video, gets infinitely small. So it goes to 0. All right, we can look at this next problem as well. So this time x is approaching negative infinity, excuse me, and then you're comparing 7, negative 20, and x cubed. So x cubed is going to be the piece that grows the most quickly. And so you have negative big because it's negative infinity. And then a negative number cubed or a negative concept cubed is still going to be a negative big. And again, in this whole rational expression, as you have a very large, even if it's negative, a very large number in your denominator, the whole fraction is going to approach 0 still. And that's because on your number line, right, if I have 0, like over here, I would have 1/10, and then 1/100th, and then this would just keep getting closer and closer and closer to 0 as the bottom of your fraction gets really small. The same thing happens even if your number is negative. So negative 1/10, negative 1/100th, and then negative 1/20, so I put 5. So either way, as the denominator of your fraction gets infinitely large, the whole fraction gets infinitely small, so it gets infinitely close to 0. All right. Let's take a look at this one. So our limit as x approaches infinity. So this one, you're just looking at the pieces. We don't have a fraction in this one. So you just look at which pieces would grow faster and dominate other pieces. So the 3x cubed is actually going to dominate. Even though the x squared has a negative 1,000 with it, as x approaches infinity, the x cubed will just completely wipe out what happens with the x squared. And so as this part grows to 3 big cubed, that's just a very big concept. So we would say that this whole thing goes to positive infinity. All right, let's look at this one. As x approaches negative infinity, so the x to the 4th is going to be the dominating piece of this equation. And so if I have negative big to the 4th, that really gives me just a positive big, right? Any negative or any number or concept to an even exponent will just always end up being positive. And so this actually also goes towards infinity. All right, here we have an example of where I noticed that my dominating piece, my x, right, that's a polynomial, I have one in the numerator and denominator of my rational expression. And so really what would be kind of happening is that you would have a big concept on top and then 3 times that same big concept in the bottom. And the 7 and the 5 become so minuscule compared to the rest of what's happening. Oh, and these are actually negatives, aren't they? So 3 times negative big. They will get completely wiped out as x approaches negative infinity. And so what kind of happens is that proportionately the top and the bottom will grow the same as x approaches negative infinity. So you can kind of think of it, very non-technically think of it as canceling out those negative bigs. And so really what you're left with is just the proportion that happens afterwards, which is 1/3. So if you have the matching dominance in the numerator and denominator of this rational expression, you can basically just take the coefficients. Here is another example of that. When looking at this whole expression, the 7x squared and the 2x squared, those are your highest polynomials, highest degree of polynomials that exist, and they match on the top and the bottom. So we would say that the coefficients proportion is what this limit of this function approaches. So 7/2. This one, you're looking at all the pieces of your rational expression, and we see that the biggest piece you have to worry about is x cubed. So as this goes towards a big cubed, which is really just big, your denominator of your rational expression gets infinitely large, so the whole thing gets infinitely small, goes towards 0. In this example, the one thing you have to pay attention to specifically when you're approaching negative infinity are signs of things. So even though the piece that we want to pay attention to the most is the 7x cubed, because it'd be 7 squared, 7 negative big squared, which would just be the squared makes it positive, and times 7 still makes it really big. So we have a giant concept on top. The one thing you have to pay attention to is what would you be dividing by on the bottom as far as signs go. We do have a negative happening, and then our x is approaching negative infinity, so negative big on the bottom as well, which would still end up being positive. Now, this is still dominating on the top, so it's going to grow infinitely large. We just had to determine whether it was going to grow towards positive infinity or negative infinity. So it actually might make, hold on, let me retry this. It might make it a little more sense to just talk about what would happen on the bottom as far as signs go. So the negative would end up going to just positive. So you'd still end up with a positive big overall. All right. Okay, when we look at this piece, the x cubed and the x cubed match, but we have this newfangled radical or square root that we haven't seen before. So your 7x and 5 become basically negligible. And so then you can have on top, you can apply your root separately to the other pieces that are still left here, right? And you're looking at it as you go towards infinity. And so then, again, non-technically, you can kind of think of it as canceling out, and you're left with the matching coefficients. So 1 over the square root of 4, which is 2. All right, let's go ahead and look at this one. This also has a square. So the 9x squared we have to pay attention to because that seems like the biggest that's happening here, but be careful because it also has a square root over it. So technically, you have to pay attention to what's also happening in the top, because when you have a big squared and the square root of it, your square and your square root cancel out. So then you're really left with the equally dominant proportions happening. So your big over your big. So then now we're left with 1/3 would be our answer. All right, we can do the same thing. This is exactly the same problem, but now x is approaching negative infinity. So let's just pay attention to what's happening. We'll have a negative big on top, and then you'll have square root of 9, square root of negative big, squared on the bottom. Negative big squared would still give me, it'd be the same as doing big squared, right? It doesn't actually matter that it's negative. So then when I cancel out my square and square root, then I have a negative big over a positive big. So your bigs cancel out, very non-technically speaking, and then you end up with -1/3. So when x approaches negative infinity, you just have to really pay attention to your signs, because that would be what changes. You'll notice that in our previous problem, we didn't have to worry about it at all because it was always a positive infinity, but for negative infinity, watch that sign at the top. All right, let's go ahead and look at this one. So I kind of will work from the inside out usually with these problems, because that's what we've been taught through all of math, is work inside your parentheses. So I notice that inside my parentheses, I can ignore the -500 and 500, because again, they'd be minuscule compared to x approaching infinity. I have matching dominance that's happening here. So really when, I don't want to say that those cancel. So you have the log, Lig. You have the log of big to the 6 over big to the 6. And so then now very non-technically we say that your bigs cancel. So really what we're finding is log of 1, which is 0. All right, I believe we got 2 more. Yeah, okay. So in this example, we have, these are all x's, again, sorry for the pixelation. So as x approaches infinity and we have these 3 exponential equations or expressions, excuse me, you have to pay attention to the one that has the largest base, which is this guy right here. And so as that goes towards big, the whole thing, since it's in the numerator of your fraction, would also go towards big or infinity. All right, last one. So this one, we have negative infinity. What's the piece that you have to pay attention to the most here? Oh, that would be the e to the 3x, because this is an exponential equation that has the largest exponent that's happening on it. So this will grow much faster. Excuse me, but we do have to kind of pay attention to the fact that it's a negative infinity. Again, that kind of trips up things. So if you have a negative exponent, so if I kind of do e to the negative infinity over e to the negative 3 infinity, remember that when you have negative exponents, and this is something we learned in pre-calculus, that these currently are on the wrong side of your fraction. And so it's easier to write it like this. Or wrong side of a fraction. It's easier to write it like this. So on top, when you have e to the negative infinity, it's really 1 over e to the positive infinity. And then on the bottom, you'll have 4 plus 5 times 1 over e to the 3 times infinity. Okay, this part goes to 0. And so does this part, because your bottom of your fractions get infinitely large. And so what you'll end up with is you'll have 0 on top over 4 plus 0. And so then total, your answer for this one would be 0. All right, so those are just some examples of practice. There are more practices for you to try as well. Please let me know if you have any questions or concerns.